Picture a wall of orange fire moving across a sawgrass prairie in South Florida. Smoke climbs into a flat gray sky. From a distance, it looks like disaster. Up close, it's something stranger, a deliberate, carefully engineered burn, set on purpose, by people trained to control exactly how it spreads. For most of the last century, fire crews lit these burns to keep the Everglades healthy. That's still true. But over the last several years, prescribed fire has taken on a second job, one that has nothing to do with nutrient cycling or invasive plants. It has become one of the only tools that can expose something the Everglades has been hiding for more than 30 years, an estimated tens of thousands of Burmese pythons, and the almost total disappearance of the animals they've been eating. This is the story of how fire, the oldest force in this landscape, became a surveillance tool against the newest one. And what it's revealed isn't just about snakes. It's about what's missing. To understand why land managers are burning python habitat on purpose, you first have to understand that the Everglades isn't just tolerant of fire. It depends on it. Long before European settlement, lightning-sparked fires swept through South Florida's sawgrass marshes on a natural cycle, often every few years. Fire cleared dead plant matter, released nutrients trapped in dry vegetation back into the soil, and kept slow-growing hardwood trees from encroaching on open marsh and pushing out the sawgrass prairies that define the region. Without periodic fire, that transition happens anyway, just messier, and on nature's schedule instead of anyone's plan. Wetland and fire ecologists have documented this fire dependency pattern across the Everglades ecosystem for decades, which is why the National Park Service and Florida Forest Service still run prescribed burns as a core part of Everglades restoration, independent of anything to do with pythons. That's the backdrop. But starting in the 2010s, land managers noticed something else happening in the aftermath of these routine burns. For a brief window, after the cover burned away, invasive Burmese pythons, normally almost invisible, were suddenly easier to find. That observation didn't turn fire into a python hunting weapon overnight. But it added a second use case to an old, well-understood tool, at a moment when the python problem had grown large enough that researchers were running out of options. To understand why anyone needs to find pythons at all, you have to go back to how they got there. And the story is less about one bad storm and more about a slow accumulation of decisions. Burmese pythons are native to Southeast Asia, and the exotic pet trade brought them into South Florida homes through the final decades of the 20th century, with the first wild sightings in the Everglades area reported in the 1980s. A hatchling python is small enough to seem manageable. But pythons don't stop growing. And an animal that starts at under 2 feet can reach 15 to 20 feet and upward of 200 pounds within a few years. An animal very few pet owners are equipped to keep. Some were deliberately released into canals and marshes at the edge of the Everglades. Then, in August 1992, Hurricane Andrew tore through South Miami-Dade County as a Category 5 storm, destroying homes, businesses, and, according to state environmental inspectors who surveyed the damage 10 days later, a number of exotic animal breeding and import facilities, including at least one python breeding operation. Witnesses reported seeing large snakes loose in the storm's aftermath. For years, this became the tidy origin story for Florida's python invasion. One storm, one breeding facility, one mass release. The real picture is messier. Researchers who've studied the timeline point out that pythons were already being reported in the Everglades before Andrew made landfall, meaning the population likely had at least a partial foothold from years of individual releases before the hurricane hit. What Andrew probably did was accelerate an invasion that had already begun by adding a large, sudden influx of animals into a landscape that had no natural predators built to stop them, and no experience recognizing the threat. Either way, by the early 2000s, wildlife agencies had confirmed the species was breeding on its own in Everglades National Park, the point past which an invasive population usually can no longer be quietly undone. What happened over the following decade is documented in some of the most sobering wildlife data to come out of South Florida in a generation. A study led by researchers from Davidson College, the U.S. Geological Survey, and several partner institutions, published in the Proceedings of the National Academy of Sciences in 2012, compared nighttime road surveys conducted across Everglades National Park in the late 1990s, before pythons were established, to surveys covering nearly 57,000 kilometers of road driven between 2003 and 2011. The results were stark. Raccoon sightings had dropped 99.3%. Opossum sightings had dropped 98.9%. Bobcat sightings were down 87.5%. White-tailed deer sightings had fallen more than 94%. Marsh rabbits, cottontail rabbits, and foxes, all common in the earlier surveys, were not detected at all during the later ones. The declines were most severe in the remote southern sections of the park, where pythons had been established the longest, and weakest at the edges of the invasion, where pythons had only recently arrived, a spatial pattern that let researchers rule out coincidence and point directly at the snake. The study's authors were careful in their language, but the implication was blunt. An introduced apex predator was exerting enough downward pressure on a mid-sized mammal community to functionally erase several species from a national park in under 15 years. As one of the study's co-authors, Virginia Tech research scientist John Wilson, put it at the time, the effects on the broader Everglades ecosystem, which extends well beyond the park's boundaries, were likely to be profound. Later research by the U.S. Geological Survey has extended those findings, tying the mammal collapse specifically to the timeline and geography of python establishment, and confirming the same pattern holds across the wider Greater Everglades ecosystem, not just the park itself. The consequences don't stop with raccoons and rabbits. The Florida panther, one of the most endangered mammals in North America, with a wild population historically estimated in the low hundreds, depends on exactly the prey base that pythons have been consuming: deer, rabbits, and other mid-sized mammals. When University of Florida researchers necropsied more than 1,700 pythons removed from the wild in 2023, they found the remains of muskrats, deer, wild boar, dozens of alligators, threatened wading birds, bobcats, and even domestic cats in their stomachs. A snapshot of just how broad the python diet really is, and how directly it overlaps with what native predators need to survive. None of this would be nearly as difficult to manage if pythons were easy to find. They are not. Burmese pythons are ambush predators with cryptic blotched coloring that blends almost perfectly into the shadows, mud, and root tangles of a sawgrass marsh. They can remain motionless for hours or days at a stretch, and they're capable of holding their breath underwater for roughly 30 minutes at a time, letting them disappear into canals and sloughs when pursued. A 2023 scientific synthesis of python biology and management, published by USGS researchers and partners, describes this cryptic coloration and low detectability as one of the central obstacles to controlling the species at all, not just to finding individual snakes, but to even estimating how many exist in the first place. That difficulty shows up starkly in the data on detection methods themselves. According to the USGS, when pythons are known to be present in an area, traditional visual searching or trapping succeeds less than 1% of the time. A field trial that set baited traps across roughly 6,000 trap nights in an area with a known resident python population caught only 3 snakes through the traps themselves, though disc-harrowing the same plot afterward, which physically disturbs and exposes the ground, turned up 11 more animals that the traps had missed entirely. That gap between how many pythons are actually there and how many pythons anyone can find is the single biggest problem in python management. And it's a problem prescribed fire happens to help solve. Here's the mechanism, and it isn't complicated. Pythons rely on standing sawgrass, and especially the dead thatch layer at ground level, the mat of dried, decomposing plant material that builds up between burns, for thermal cover, ambush positioning, and concealment from predators and researchers alike. Burmese pythons are ectotherms. They cannot regulate their own body temperature and depend entirely on their surroundings to do it for them. When a prescribed burn removes the standing grass and the thatch layer down to bare, blackened soil, it strips away both the camouflage that hides a tan and brown snake and the thermal buffer that lets it sit still in direct Florida sun. The snake has to move to find new cover, and for a short window, until the sawgrass resprouts, which in Florida's climate can happen within days. Python removal crews have something they almost never get in the Everglades: a clear line of sight. That short window is also when newer detection technologies work best. Thermal cameras that struggle to read heat signatures through dense standing vegetation get a much cleaner signal against open, cooled ash. Drone operators can fly a burned unit and visually scan bare ground from altitude in a way that's simply impossible through a sawgrass canopy. And environmental DNA sampling, a technique where researchers filter water samples from marshes and canals to detect trace genetic material that pythons shed into their environment, has emerged as by far the most effective detection method available. According to USGS research, EDNA sampling can achieve detection rates above 90% in areas where pythons are present, compared to the sub 1% success rate of physical searching. EDNA can't tell a removal crew exactly where an individual snake is coiled, but it can confirm occupancy in specific marshes and tree islands that would otherwise be impossible to survey on foot, including, research has shown, wading bird breeding colonies, where python presence poses an outsized risk to already vulnerable bird populations. The actual removal work falls to a small, contracted workforce operating under two parallel state and regional programs. The Florida Fish and Wildlife Conservation Commission runs the Python Action Team, removing invasive constrictors, known as Patrick, and the South Florida Water Management District runs its own Python Elimination Program, launched in 2017 at the direction of the state government, specifically to scale up removal effort. Together, the two programs maintain a roster of roughly 50 to 100 trained, paid contractors with access to designated public lands across South Florida, including the Francis S. Taylor Wildlife Management Area, Big Cypress National Preserve, and sections of Everglades National Park. The pay structure reflects how physically demanding and how uncertain the work is. Contractors are paid an hourly rate for time spent actively searching, on top of per snake bounties that scale with the size of the animal caught, because a great deal of the job is simply walking through marsh at night and finding nothing. As of April 2025, the two programs combined had removed more than 23,500 pythons from Florida's wild lands since the effort began, with more than 11,000 of those coming specifically through the contracted Patrick and Python Elimination Program agents. One of the state's best-known contractors, Donna Khalil, a former businesswoman who became one of Florida's most prolific licensed python hunters, has described the animals she catches as capable of eating almost anything they can physically overpower. Of one large python she caught near a residential canal, she noted plainly that at this size it can definitely take your cat and dog. Some of the program's methods borrow from expertise that predates any of this American technology. FWC and university researchers have worked directly with Irula tribesmen from India, a community with generations of traditional snake-catching skill, historically used to safely capture venomous cobras for anti-venom production, bringing that hands-on tracking knowledge to Florida to train contractors in reading subtle signs of python presence that cameras and sensors still miss. Radio telemetry adds another layer. Researchers implant transmitters in captured male pythons, then release them and track their movements during breeding season, when they travel to find receptive females. These so-called Judas snakes have led removal teams directly to breeding aggregations. A single successful track can lead to the removal of several large, reproductively active animals at once, disproportionately reducing future egg clutches rather than just adult numbers. It would be misleading to end this story with fire and drones riding to the rescue. The honest picture is more limited, and researchers involved in python management are candid about that. Population estimates for Burmese pythons across South Florida remain genuinely uncertain, with figures published in past years ranging from the tens of thousands into the low hundreds of thousands, precisely because the species is so difficult to survey with any precision. A single female can lay up to roughly 100 eggs in a clutch, and researchers studying python life history have noted that even with high juvenile mortality, that reproductive output makes population control through removal alone an extremely steep uphill climb. Contractors are, by design, removing individual animals from a population that keeps replacing itself faster than any current effort can match at landscape scale. The USGS's own synthesis of the science is blunt about the ceiling on what's achievable. Full eradication across the python's current range in southern Florida is not possible with the tools that exist today. Traps remain unreliable. Pythons don't readily enter them, and researchers who've tested attractant traps in the field have found capture rates far below what would be needed to meaningfully suppress a population. Fire only helps in the specific units that get burned, on the specific timeline before vegetation regrows, and prescribed burning itself is a slow, tightly regulated process. Land managers need particular combinations of humidity, wind direction, and fuel moisture before they can safely light a unit at all, which limits how much python habitat can realistically be burned in a given season, let alone across a footprint spanning multiple counties. That's part of why researchers have increasingly turned toward biological approaches still in early stages of development. USGS scientists and university partners are actively researching genetic biocontrol, techniques that would introduce heritable genetic modifications designed to skew python reproduction toward, for example, producing overwhelmingly male offspring over generations, gradually collapsing a population's ability to reproduce. It's a promising avenue precisely because it doesn't depend on physically finding every snake. But it remains an active area of research rather than a deployed tool, and scientists working on it have been explicit that establishing reliable python vital rates, survival, reproduction frequency, and dispersal patterns is a necessary foundation before any genetic approach could be responsibly tested at scale. None of this makes for a tidy ending, and that's probably the most honest thing to say about it. The Everglades didn't lose its rabbits and raccoons overnight, and it isn't going to get them back overnight either. What prescribed fire offers isn't a solution to the python invasion. It's a temporary window of visibility in an ecosystem that has spent 30 years learning, one predator at a time, how to disappear. The smoke clears. The grass grows back within days. And somewhere out past the ash line, the sawgrass is already closing the curtain again, until the next burn, the next window, and the next attempt to see what's actually still out there.